Hi everyone, welcome to PharmaGrid. Today's video is about structure-activity relationship. As you all know, the biological effects of a new chemical compound can often be predicted from its molecular structure using data about other similar compounds. This is because similar compounds may have similar physical and biological properties. So there is a relationship between molecular structures and their biological activity, and this principle is referred to as structure-activity relationship. So my first video is about the structure-activity relationship of barbiturates. The pharmacology of barbiturates I have already discussed in the anxiolytic and hypnotics chapter. So those who haven't watched that video, please go and watch that video. So today we will discuss about the SAR or structure-activity relationship of barbiturates. So before learning this structure-activity relationship, it is very important to know the functional groups as well as the basic ring system that will help you to easily identify the structures as well as their structure activity relationship. So regarding these barbiturates are cyclic urides and are formed when a dicarboxylic acid reacts with a urea. Many cyclic urides are derived from malonic acid or malonic esters. They are collectively known as barbiturates because of their relationship of malonyl urea or barbituric acid. The basic structure of barbiturates is derived from barbituric acid, which contains a six-membered pyrimidine ring with two carbonyl groups at the 2 and 4 positions and two nitrogen atoms at positions 1 and 3. Okay, so this is the basic structure of barbituric acid. Okay, this is a six-membered pyrimidine ring, and it consists of two nitrogen atoms in the first and third positions. Okay, so the numbering will start from either one of the nitrogen atoms, and you can see carbonyl group is also known as keto groups in the 2, 4 and 6 positions. Okay, so this is the general structure of barbituric acid, and if you know the basic structure, so you can easily identify the specific drug, especially in case of your exams. So this barbituric acid does not possess any hypnotic properties. So as I have already mentioned, the barbiturates are derivatives of barbituric acid, and this is the basic structure of barbituric acid. And here you can see the general structure of barbiturates. And numbering is like this. First nitrogen. Either nitrogen can give the first number. So we can give it like this. Here first position. This is second, third, fourth, fifth and sixth. Okay, so this is how the numbering goes. And R1 represents the R1, R2, R3 and R4 represents the substitutions. Okay, so these all are the positions where substitution occur. Okay, because of this substitution, the structure activity relationship as well as the compounds differ based on these substitutions. The barbituric acid itself does not possess any hypnotic properties. It is only when the two active hydrogen atoms at a position 5 have the appropriate substituent. This appropriate substituents can be either alkyl or aryl groups that the hypnotic activity is produced by the compound. Okay, so these all are the substitutions, major substitutions. That is, first one is C1 position, then C3 positions as well as C5 positions. Out of these, the carbon 5 or fifth position has got greater importance in the structure activity relationship of barbiturates. A good hypnotic barbituric acid derivative must have the following properties. So from the word itself, that is, barbiturates are derivatives of barbituric acid. So these barbiturates have acidic properties. So the first one is the acidity value. It should be within certain limits to give proper ratio of ionized and unionized forms, which is important to cross the blood-brain barrier. It takes approximately 40% to 60% dissociation to enable a barbiturate to cross the blood-brain barrier and exert effects on CNS. Determination of the pKa can thus be predictive of the CNS activity. Next property is the lipid water solubility, which is the partition coefficient. It should be in certain limits. So this barbituric acid exhibits keto-enol tautomerism. That means barbiturates exist in two molecular forms, that is enol and keto forms. This enol forms for barbiturates are water soluble at pH 10 to 11. Therefore, in the injected form, the drug is not initially lipid soluble and would not be expected to enter the brain readily. Okay, so once in the circulation, the enol form. Okay, so this is the enol form. So once in the circulation, the enol form undergoes a structural change called a tautomerization to a keto form, which is more lipid soluble. Okay, so this is known as the keto-enol tautomerism. This is a equilibrium condition. So here are some general rules regarding the structure activity relationship of barbiturates. So in the previous slides I have already mentioned that mainly in this barbiturates, substitutions mainly occur in the first position, then second position as well as in the fifth position, and the fifth position is the most important one. So starting with the first position, if if the first position is substituted with a small alkyl groups, it will increase the lipophilicity. So increased lipophilicity means that can penetrate the blood-brain barrier or can penetrate the CNS very fastly. So such drugs will have faster onset as well as short duration of action. Now the second position. In the second position, already there is a ketone group or carbonyl group. So the replacement of oxygen in the second position by the sulfur atom at second position or C2 position, it leads to rapid onset and shorter duration of action. For example, thiopental. So in thiopental, we already know it is an ultra short acting barbiturate. The main use of ultra short acting barbiturate is to use as an intravenous anesthetic. So here you can see the structure of thiopental. So this is the basic structure of barbiturate, and in thiopental the peculiarity is that the second position is substituted with a sulfur atom, and this substitution contributes to the rapid onset as well as shorter duration of action of this thiopental. So that is why it is classified as an ultra short acting barbiturate. Now the most important position, that is the fifth position. Okay, so concerning the fifth position, the most important points are, first one is, see the general structure. This is the fifth position or the fifth carbon. It must be di-substituted. Okay, that is the two hydrogen atoms in this fifth position must be replaced. That is R3 and R4. Okay, so that is the fifth position must be di-substituted. Now the next point is, higher the total number of carbon atoms in the fifth position, shorter the duration of action. So the first point is, the fifth position must be di-substituted, and the total number of carbon atoms in this position is very important. If the total number of carbon atoms in the fifth position is more, it will decrease the duration of action. Okay, that is the total number of carbon atoms present in the two groups at the carbon 5 must not be less than 4 and more than 10 for optimum therapeutic results. The sum is also an index of the duration of action. See this table. If the sum of this total carbon atoms is in between 7 to 9, these drugs have got rapid onset and shortest duration of action. And if the sum of value is between 5 to 7, intermediate duration of action. If the sum of value is 4 or less, slowest onset and longest duration. Okay, in such drugs, those drugs will have two ethyl groups or ethyl and phenyl groups in their structure. Okay, so the point to be noted is that the fifth position must be di-substituted, and if the total number of carbon atoms in the fifth position is higher, it will decrease the duration of action. Okay, so this total number of carbon atoms as well as the duration of action is inversely proportional. And the next point is the nature and branching of chain as well as unsaturation. Unsaturation means presence of double bonds, triple bonds or ring systems. Okay, if there is unsaturation means it will increase the lipophilicity. Increase lipophilicity means it can enter the central nervous system very fast. That will lead to shorter duration of action. Within the same series, the branched chain has greatest lipid solubility and hypnotic activity but has shorter duration of action. Branched cyclic or unsaturated chains at C5 position generally reduce the duration of action due to increased ease of metabolic conversion to more polar inactive metabolite. The greater the branching, more potent will be the drug. For example, pentobarbital is more potent than amobarbital. Here you can see the structures of both pentobarbital as well as amobarbital. So consider the fifth position. In pentobarbital, the C5 position, these are the two substitutions, and here the branching is from the first carbon. Okay, branching is from the first carbon, and this is the structure of amobarbital, and here you can see the substitutions at the fifth carbon position. Okay, fifth carbon, and here branching is in the third position. So hence why this pentobarbital is more potent than amobarbital. So concerning this fifth position, alkyl substitutions at the C5 position influence the lipid solubility and thus the onset and duration of action of the barbiturate. For example, increasing the chain length of the alkyl groups generally increases the lipid solubility, leading to a quicker onset and shorter duration of action. For example, pentobarbital and a secobarbital. Okay, see the structures of both this pentobarbital as well as secobarbital. This is the fifth carbon. Okay, fifth carbon, and it is di-substituted. And here you can see the increasing the chain length. Okay, here the chain length is high in both pentobarbital as well as secobarbital. Both these drugs are Short acting barbiturates. Okay, short acting barbiturates. This increasing the chain length of alkyl groups generally increases the lipid solubility, leading to quicker onset as well as shorter duration of action. Then double bonds in the alkyl substituent groups. As I have already mentioned, unsaturation. Okay, double bonds means unsaturation. So unsaturation in the alkyl substituent groups produce compounds more readily vulnerable to tissue oxidation. Hence, they are short acting. In secobarbital, you can see this unsaturation. Okay. So now let's have a look into some of the important structures of barbiturates. So the first one is barbital. Here the general structure is same. Okay, always memorize the basic structure so that it will be easy for you to identify the specific drug. So in the first and third position there is nitrogen atoms, and in the second, fourth and sixth positions ketone group. So in barbital, the fifth carbon is substituted with the two ethyl groups, that is C2H5 groups. Okay, so this barbital is also known as 5,5-diethyl barbituric acid. So now consider the total number of carbon atoms in the fifth position. So the total number of carbon atoms is 4. Okay, so lesser the number of carbon atoms in the fifth position, longer the duration of action. So this barbital is a long acting barbiturates. Now phenobarbital. In phenobarbital, remaining all other structures are same. Only the difference in the fifth carbon. In the fifth carbon, one substitution is ethyl group and the next substitution is a phenyl group. Okay, phenyl group. So this phenobarbital is also known as 5-ethyl 5-phenyl barbituric acid. So in this phenobarbital, the total number of carbon atoms in the fifth position is about 5 to 6. Okay, so less number of carbon atoms. So phenobarbital is also considered as a long-acting barbiturate. Now mephobarbital. Mephobarbital is also the same. Okay, same as that of phenobarbital. Only the difference in the methyl group. Okay, a methyl substitution in the first position. Okay, methyl substitution in the first position. This is the only difference with this mephobarbital. Remaining all others are same. So this mephobarbital is also known as 1-methyl 5-ethyl 5-phenyl barbituric acid. The fifth position is substituted with an ethyl and a phenyl group. So the total number of carbon atoms is approximately 5 to 6. So this mephobarbital is also considered as a long-acting barbiturate. Now this amobarbital. In amobarbital, the fifth position or fifth carbon is substituted with a one ethyl group and the second one is 3-methyl butyl group. Okay, so this amobarbital is also known as 5-ethyl 3-methyl butyl barbituric acid. So if we consider the total number of carbon atoms in this fifth position, it will be 2 plus 3, 4, 5, 6 and 7. So in amobarbital, the total number of carbon atoms in the fifth position is approximately 7. So this amobarbital is considered as an intermediate acting barbiturate. Next is pentobarbital. In pentobarbital, the fifth position. Okay, so the remaining all other structures or functional groups are same. Only the difference in the fifth position. So in the fifth position, one substitution is the ethyl group and the second substitution is the 1-methyl butyl group. Okay, so this pentobarbital is also known as 5-ethyl 1-methyl butyl barbituric acid. So in pentobarbital, the total number of carbon atoms in the fifth position is greater than 7. Okay, so greater than 7. So this pentobarbital is considered as a short-acting barbiturate. Now the secobarbital. Secobarbital, see the fifth position. So secobarbital is also known as 5-1-methyl butyl 5-prop 2-enol barbituric acid. Okay, so here you can see the unsaturation as well as the total number of carbon atoms in the fifth position is greater than 8. Okay, so this pentobarbital as well as secobarbital are considered as short-acting barbiturates. Now the last one is ultra short-acting barbiturate. For example, is thiopentone as well as methohextone. The structure I have already discussed in the previous slide. In thiopental, the total number of carbon atoms in the fifth position is greater than 7. And one more thing, in the second group, that is in the second position, the oxygen is replaced by the sulfur atom. So all these contribute to the ultra short-acting property of this thiopental as well as thiopental. Stereoisomers have more or less the same potencies. Aromatic and alicyclic moieties exert greater potency than the corresponding aliphatic moiety having the same number of carbon atoms. Short chains at carbon 5 resist oxidation and hence are long-acting. Long chains are readily oxidized and thus produce short-acting barbiturates. Okay, so it's the same principle here. The higher the total number of carbon atoms in the fifth carbon, shorter the duration of action. Then introduction of a halogen atom into the C5 substituents increase the potency, whereas the introduction of polar substituents, for example OH, NH2, COOH, CO, RNH and SO3H into the aromatic group at C5 results in decreased lipid solubility and potency. Then inclusion of a more sulfur atoms, for example 2,4-dithio, 2,4,6-trithio decreases the activity. Likewise, introduction of imino groups into the barbituric acids abolishes activity. For example, 2-imino, 4-imino, 2,4-diimino and 2,4,6-triimino. Then the replacement of the hydrogen atom at the carbon atoms 1 and 3 with an alkyl group increases the vulnerability of the molecule to tissue oxidation. So in this slide, I have included the classification of barbiturates. Okay, these barbiturates are mainly classified as long acting, intermediate acting, short acting as well as ultra short acting based on their duration of action. So the first classification is the long acting. Here these drugs have duration of action greater than 6 hours. Okay, examples include barbital, phenobarbital, mephobarbital as well as methabarbital. So here you can see the substitutions. Okay, R1 means the C1 substitutions and R5 and R5 dash means substituents at the fifth carbon. Okay, so note down the what are the changes in the substitution so that you can easily identify or you can easily find out the difference between different structures. Next is intermediate acting. Here duration of action is between 3 to 6 hours. Examples include amobarbital, butabarbital, eprobarbital, talbutal, butabital and hexabarbital, and see the substituents also. Next is the short acting. Here short acting duration of action is less than 3 hours. Examples include pentobarbital, secobarbital, cyclobarbital and heptabarbital. Then last one is the ultra short acting. Here the duration of action is within 15 minutes. Examples include thiopentone as well as methohexadone. So I hope the structure activity relationship of barbiturates is clear for everyone. If you have any doubts, you can mention in the comment section. Thank you everyone. Thank you for watching this video. Have a great day.